presentation my current research entitled Shear Deformation of Unsaturated Soil due to change of water content under constant stress. So I will divide my presentation into 6 parts. First one is background. This is a picture of landslide caused by rainfall. Rainfall-induced landslide is a major type of landslide happen around the world. In most of natural slope, soil is in unsaturated condition, where the existence of water can make a bond between soil particles through surface tension. And in this condition, the value of pore water pressure is negative, and we can quantify the strength as suction, which is the difference between pore air pressure and pore water pressure. However, when a higher amount of water infiltrates the soil structure, pore water pressure become increasing, and this suction will become less and make soil structure fail. To mitigate landslide disaster, applying soft measure by monitoring system is the best choice because it's more economical. And using the data obtained, we can observe slope movement and issue early warning. However, we still need to know the mechanism or the condition leading to failure, because we can issue warning properly. And to do that, we can reproduce soil condition in the slope in laboratory tests. Here's an example of model test studying the effect of water content to soil deformation, and we can correspond the response in the soil deformation in lab with tilting angle in the real monitoring meter. So based on those backgrounds, my objective in this study is to study the behavior of unsaturated soil in slope under condition of constant stress, repeated drying wetting cycles, and by observing shear deformation, water content, and suction history. My methodology is to reproduce soil under constant combined stress, which represent soil depth and angle stiffness. And to represent rainfall and drying condition, water is injected and drained from top and bottom side of specimen. The benefit of using simple shear apparatus is because the specimen is small, it's relatively easier to achieve moisture uniformity when injecting water comparing to other apparatus. And it also represents common type of deformation that happen in natural slope. My apparatus consists of loading system and sensor system. 2 bellophram cylinders are used to give shear load and axial load. And there are several sensors measuring displacement, changing of water volume, and pressure or water pressure. And here the shear box, it consists of 10 Teflon sheet layer, which has low friction. And also there are 2 ceramic discs in bottom and top part to inject water. And the material I use is Edosaki sand. To make sure that the apparatus is working properly as desired, I did some modification. First, to measure soil suction, I made small suction sensor, which basically measure pore water pressure. It is made from aluminum tube wrapped by special membrane. The hose has flexible part to avoid disturbance to soil structure. Then, because there is a risk of slippage in interface between ceramic disc and specimen, an additional friction was added by attaching sandpaper in the surface of ceramic disc. And here is one of the results of my test. In this test, I was simulating a condition of slope that is subjected to rainfall, dry condition, and then rainfall again until it reaches some failure point. Here we can see 2 graphs with shear strength in horizontal axis and vertical axis. We have volumetric water content in the upper graph and water pressure in the lower graph. We can see the deformation rate become slower and tend to stop in drying condition. While after I inject water again, the deformation start to redevelop after volumetric water content exceed the previous maximum value. This result is agreed well with previous study by Suzuki in 2011 using model test. And we can see I applied drying in the middle of the transition zone in Cartesian graph. And because suction represents different strength state of soil, it also gave different response in deformation rate. And my future plan in this research is I will conduct other tests with another variable combination to represent different conditions in slope. such as a different stress ratio, rate of water injection, changing water scheme, and combined scheme. I will also do further analysis of the relationship of suction to deformation rate in drain wetting condition. And here's my conclusion from this current research. Modification to simple shear apparatus are reliable to be used. Wetting drain stage cause difference in soil deformation rate during rainfall process on slope, and suction play a role in affecting deformation rate. Thank you.
What is the different point of your research from that Suzuki-san's research to your research?
Oh, okay. In this research, I conduct simulation using element test, while Suzuki-san conduct in model test, and I also measuring the suction of the soil. So I want to observe the history of suction and what is the effect to deformation rate.
Why didn't you show that this is called?
This
That's 3D.
The orange graph is showing suction graph, but I just in this case I just conduct one cycle of drain wetting, while in the next plan I will conduct several number of drain wetting.
In the lower figure, water pressure after shear strength is 10%, around 10% is almost constant, while volumetric water content continues to increase. What is happening there?
Sorry, can you?
In the lower figure, on water pressure, on the right-hand side is kept almost constant at -5 kilopascal. But at the same time, volumetric water content is increasing. Yeah. So while keeping the constant suction, shear strain is increasing. Do I understand you correctly?
I think during this period, I just understand at this part where it just increased suddenly, because at that part I think there is some failure occurred.
Where failure?
In this point.
Yeah, but before failure, suction is kept constant, tentatively. Do I understand you?
Yeah. For this case, I was discussing with Sensei that maybe my stress ratio here is not enough to reach failure. So in the next test, I will conduct with higher shear stress to achieve that failure. So probably in this test, even we can see like some sudden increase in strain here and sudden increase in pore water pressure. Yeah, probably the shear stress ratio on that specimen hasn't exceed the failure line of the soil.
But you still want to assume that your specimen is uniform.
Okay.
But I'm afraid I do not agree without any evidence. Okay. So please try to prove that. My point was this pore water pressure was measured at one single point, which may not be representative of the other. What is that issue?